the application layer, we also have a bunch of protocols that allow these applications to define how communication should proceed between the sending application and the receiving application. And so certain protocols need to be specified here. So the domain name system allows us to specify a protocol which we can use to create domain names. These are used for the World Wide Web application to implement the hyperlinks in order to link documents together. So let's look at the DNS. Domain name system. It's a hierarchical domain-based naming scheme and a distributed database system that manages names. And what it does, it maps these names into corresponding IP addresses. So the reason we have this domain name system is because in order for us to connect from the client to the server, let's say this is a web browser that wants to request a web page from a web server. In order to connect to the web server, it needs to establish TCP connection with the server. Remember the three-way handshake? That's what it needs to do. To do that, we remember we had to use a socket, and the part of the socket was the IP address of the machine that we're trying to connect. So if the web browser is going to connect to the web server to request a web page, it needs to know the IP address of the server that it's connecting to. So remember that the IP address was the address that uniquely identifies that machine. It was similar to the post office address, to our delivery address. If we were to send a mail, a package, or a letter to somebody, we have to specify the address of where it's going to and where it's coming from. And that's the IP address in our case. So for the client, our web browser, to connect to the web server, all it needs to know is the IP address of the server. But we, as humans, can we remember these IP addresses all the time? So if we want to connect to google.com, instead of saying google.com, we need to know the IP address of Google. Because that's what the network needs to connect to it. The network doesn't understand google.com. It needs the IP address of Google. So for us to make our life easier, we created this domain name system so that instead of using IP addresses, we can use names that we can easily remember. But to make that work, we need to create a database that maps these names to the corresponding IP address. And so before the web browser can connect to Google, it needs to first contact DNS server and obtain the IP address of Google so that it can connect to it. So that's what the domain name domain system is doing. And the way it works is that we divide the namespace. We have 250 top-level domains, and these are .com, .net, .edu, .org, and each one with specific purpose. So com is for commercial, edu for education, this is organization. Then we have the country codes. Netherlands, United States, Japan, Australia, and so on. Underneath is second level domain. So for example, under EDU we have Washington or UNCC or MIT or another subdomain. And underneath that we could have a third level subdomain, computer science. Underneath that we could have a robot. So it's going to be robot.computerscience.washington.edu. But the high level domains are controlled by a central authority that makes sure that there's no two different organizations with the same domain name. Because the IP address is unique. Right? This is the address that uniquely identifies the machine on the network so that we know where is the sender and where is the receiver. And we don't want to have 2 or 3 different names mapped to that address. So we don't want to have more than one address assigned to same address assigned to 2 or 3 different machines, because then we would know which one the packet is addressed to. So what we want to do is to make sure there's one unique domain name per IP address. So for example, if we, let's say, create a new company and we want to obtain a domain name for that company, and we say, okay, give us the name Microsoft.com. Well, we can't give that to you because somebody already has that. Otherwise, if we give it to you, then it's gonna be messy. We won't know which one is the Microsoft added to. So if the way it works is .com, .gov, .edu are assigned according to their specific purpose. Let's say commercial, government, military, and so on. And then we have these DNS servers that are handling a part of the domain space. When we said here it's a distributed database system, why is it distributed? Why can't we just have one big server that has all this information in it? But it has to be distributed amongst multiple machines like that. What happens if this stops working? What if the DNS doesn't work anymore? So web browser wants to connect to google.com and DNS doesn't work. What's going to happen? Can it still connect to google.com?
Well, not google.com.
Unless it knows the IP address of Google, right? You can connect. But if it doesn't know it, it's not gonna work. So we don't want to put all of our eggs in one basket, because if that huge server with all this information gets hacked or compromised in some way, then big part of the internet is not gonna, of the World Wide Web is not gonna work, because the clients wouldn't be able to connect to the servers because they don't know their IP addresses. So we have zones. We divide this into zones, and each zone is handled by one DNS server that contains information for that particular zone. Other things that we have in this layer, other applications, is, as we mentioned, is the email. So we have another protocol that specifies, so let's look at protocols here. DNS, we have simple mail transfer protocol in this layer, which specifies the rules of how we can send and receive emails. So how email clients can connect to email servers and send and receive email messages. We have two subsystems. One is the client system or sending agent. This is pretty much our email application, client application that we all see where we log into our email, that allows us to compose messages, search through our messages, delete them, and so on. This is the client's interface. And then we have a server agent. That is the web server that the client connects to. It's called a message transfer agent. So it's going to route the email message to the appropriate email server. When it's received there, then the receiving agent can connect to it and obtain that email. The protocol, the way it works, it pretty much creates an envelope similar to when we send regular mail on the paper. So it has the name of the person that's going to receive it, the name of the person that sent it, subject, and so on. And then is the actual message or data. So we do attach this header to the message, which contains the simple mail transfer protocol control information that is used by the email client and servers. This is some of the information that is in the header, to whom it's going to CC from, return path, date, and so on. Now we do have something that we use for emails called MIME. That is multi-purpose internet mail extensions and this allows for non-English characters such as languages with accents and Chinese alphabet and things like that, or French or German or some other language to be used. It also allows for text, audio, and video and other applications to be sent through the email other than just English text. So all of these types are specified in the MIME extensions, like type text. It can be plain text, HTML, XML, or so on. Image, what type of image? GIF, JPEG, GIF, audio, video, or an actual binary application in the email. And the SMTP protocol, the way it works is that we have the server is being bound to port 25 on the receiving machine. So remember, when we're establishing TCP connection, we have to use a socket. The socket contains the IP address, but also the port number and the ID of the process that is using it. So for email, we were using port 25. So on the receiving side, there is a webmail daemon or service that is always sitting there listening. So it's bound itself to port 25. It's listening for new connections or incoming mail. The client will send a connection request, and so the client commands are defined in order to send and receive email, are defined in the SMTP protocol, and they are 4-letter words. Like, for example, the first thing the client has to say is hello, so it's HELO. And then it says, I have mail from such and such sender, should be received to such and such sender, and here's the data. So the SMTP protocol defines these commands for the client, and for the server, it defines the responses that the server can send back to the client. For example, the server says a code called 220. So that means the server is ready, and it's listening for new emails. And there's a bunch of other codes, like 250, 384, and so on. And so then the message comes, says, happy birthday to you. Then the server says the message is accepted, and then the client quits and the connection is closed. So this is what happens when we send and receive emails. And let's look at the World Wide Web application.